Let's move on to Module 4, Chemical Safety. In this module, we will be reviewing chemical labeling, proper storage, and chemical waste disposal. Let's start by reviewing chemical labeling. All original chemical bottles purchased from the manufacturer are required to have GHS labeling. GHS labeling is the globally harmonized system of labeling, and each bottle will contain pictograms that indicate the chemical's physical, environmental, and health hazards. For chemicals that are not in the original container, such as this one, they will need a hazard warning label. These labels can be provided to you by EHS. Remember to check your chemical's SDS for important information about reactivity, proper gloves to wear, disposal, and cleanup procedures before you begin working with chemicals. You can find the SDS information on our ChemWatch link, and you can access that through the Scripps intranet main page or the EHS main page. Proper chemical storage involves segregating your chemicals by compatibility and hazard, not necessarily alphabetically, because that can be more dangerous if chemicals leak or spill and potentially cause a reaction. For example, let's take a look at how to properly segregate acids based upon their compatibility. Use secondary containment bins to help segregate your acids. You want to store your inorganic acids like hydrochloric and sulfuric separately from the organic acids like acetic and oleic acid. Oxidizing acids such as perchloric and nitric acid should be kept separate from the other acids because of their reactive properties. The fire department requires that all flammable chemicals be stored in designated flammable safety cabinets such as this one. When you're working with flammable materials at the bench, you want to use it in a container with a capacity no greater than 500 milliliters, like this one. You want to avoid storing flammable materials in a regular refrigerator or freezer. Make sure that you're storing them in an intrinsically safe refrigerator or freezer. One way you can tell is that the electrical components are located in a box on the outside. Whenever you're working with hazardous chemicals, you want to make sure that you work inside of a chemical fume hood. Before you begin working, make sure that you're wearing the appropriate PPE, a chemical lab coat, gloves, and safety glasses. Here are some safety tips to ensure that the hood is providing you with adequate protection. Fume hoods are powered by an exhaust fan on the roof that draws air up from the fume hoods through ducts and pushes the air out through an exhaust stack. We need to verify proper hood airflow to make sure contaminants aren't affecting you. That's why there is an airflow indicator that will alarm if the airflow is too high or too low. EHS staff certify and test all fume hoods on campus annually to make sure that the airflow velocity is adequately protecting you. The sash on a fume hood slides either vertically or horizontally and is designed to shield you from chemical splashes, flying debris, or inhalation of chemical vapors. Make sure you are working with the sash as low as possible and also work at least 6 to 8 inches inside the hood for your protection. Here are some examples of common chemical waste containers that you'll see in the lab. Some things to remember about waste accumulation is that you want to have a hazardous waste label on every chemical waste container, such as this one. Make sure that you fill out all the information on the label, especially the accumulation start date. This is the date that you first add waste into the container. This yellow debris bin is for chemical contaminated laboratory debris. If you have chemical contaminated sharps waste, such as razor blades, needles, syringes, they will go in a yellow sharps container with a hazardous waste label. A common collection container for liquid solvent waste would be these red safety cans, but you can use other containers such as this reusable container here as long as it has a closing lid. Funnels that have closing lids are acceptable as well. It is good practice to have secondary containment around your waste containers to prevent spillage, and make sure that all containers are kept closed when they're not in use. Before you dispose of any chemical container in the regular trash, you want to make sure that it's completely empty. The term California empty means that if you invert the bottle, no pourable liquid comes out. Then it's ready for disposal. If there is residual liquid left inside, pour it into a hazardous waste container before disposing of the bottle. Once you verify that the bottle is completely empty, go ahead and deface it and then put it in the glass box for disposal.